Hello guys, welcome to Amazing Engineering, and this is the first video tutorial of GeoGebra where we will analyze and design a series of mechanisms. Today we will start with a simple 4 bars mechanism like this, and as first we have to set the coordinates of the fixed edges D and A. For example, the coordinates of D are 0, 0, and the coordinates of A are 10, 0. Now we have to create a series of number sliders which represent the length of the member of the mechanism. For example, the first slider is called M2, which means the second member of the mechanism, and its value varies between 0 and 5. Then M3, the third member of the mechanism, whose value varies between 0 and 10. And the last one is M4, the fourth member of the mechanism, whose value varies between 0 and 5. So, for example, the length of the second member is equal to 3. The length of the third member is equal to 8, and the length of the first mechanism is equal to 5. Now let's create a circle whose center is the fixed NGT and the radius is equal to M2. Now we have to choose a point on this circle, for example this one. Let's create an angular slider whose name is alpha, and its value varies between 0 and 360 degrees, and it represents the angle of the crank. Now what we have to do is to create a new point whose coordinates vary according to the values of the angle. So click on angle with given sides, click on the point, then on the center of the circle. The value of the angle is equal to alpha. You can choose between a clockwise and a counterclockwise rotation. Click on OK. And this new point represents the mobile hinge C. So we can call it C. And if we change the value on the angle alpha, we can change at the same time the coordinates of the point C. Now, in order to get the coordinates of the second mobile hinge B, we have to remember that during its absolute motion, B describes a circular trajectory with whose center is A, while during its relative motion with C, B describes another circular trajectory whose center is C. So we have to create a first circle whose center is C and its radius is equal to M3, and another circle whose center is A and its radius is equal to M4. Now we have to get the intersection points between the two circles. You can hide one of these points, or you can choose one of the two intersection points, setting the first or the second intersection. In this case, we can choose the first intersection. Let's call it B. let's link the points with segments, and this is the 4-bar mechanism. Now if we click on animation on the angular slider alpha, we can see the motion of the mechanism, and you have to pay attention to the length of the member, because you have to remember that the point B is the result of the intersection of two circles. So if during motion there is no intersection between the two circles, the mechanism will disappear. So for example, if we reduce the length of the third member and we click on animation again, we can notice that after a certain value of the angle, the mechanism disappears. You can also change the size of the links and their color. And if you choose a point of one of the members of the mechanism, for example this point, if you click on Show Trace and click on Animation, you can see the trajectory which the point describes during the motion of the mechanism. This is all for today, and in the next video we will set the kinematic analysis of the mechanism, calculating the values of velocity and acceleration of the 2 points C and B. Okay guys, this is all for today. I invite you to subscribe on my channel and see you for the next video.